Namaste everyone, and myself, S.S.Takalkar, of course, your friendly teacher. Dear friends, today we are going to study more details about the isothermal and adiabatic processes, reversible processes. Before going to study these are different processes, that is what is meant by process, what is meant by state of system, what is meant by thermodynamic levels. Let us study one by one. This system here, it is, that means it can be changed with the surrounding. There is a frictionless piston weightless, and on this piston there is applied the pressure. Okay, this system consists of, suppose, ideal, and therefore PV is applicable for the ideal gas, and this gas exerts a pressure. This is known as the force here, internal, that is the pressure due to the ideal gas which is enclosed in this system, right? So here, dry. Suppose it is about 1 kg or 10 kg and attain equilibrium. This is P external. This is P external. Okay, this is P external. Right? This is a flexible system. So this piston can be go up or can be compressed the gas because of this one. Now, if the small particle or some of the mass is taken. So what happens? So by some amount, say d, very small, infinitesimal. What is that? Infinitesimal change. So we change the pressure by very small amount, right? So the is more than the opposing force. P external, that is the opposing force. Start when the system is said to be at equilibrium. The opposing force and driving force, they are balanced, right? They are same, but as the opposing force is infinitesimally decreases by very small amount, imaginary amount dP, then what happens? Of course. So in this case, what happens? The piston displacement taking place, and displacement taking work can be done, right? Small work can be done by the system, right? So energy from the system is utilized to done the work, that is the displacement taking place. Process taking place. So here E. Now this is the system. E, it has P1. That is the pressure. Whatever is the value and temperature, etc. The known set of all thermodynamic variables. Okay. So this when the system or the pressure, value, temperature, the system is is said to be in a particular state. So this is suppose state 1 or initial. Now, if one of the thermodynamic change, right? Suppose you change the pressure, right? Here it is shown here, very small amount. If you decrease the pressure, so what happens? Force becomes more than the opposite force, and volume increases. So one of the thermodynamic variable is going to change. The corresponding change can be occur in a particular thermodynamic variables, right? So if you keep the temperature constant, and if you, what is the effect on the volume? Of course, according to the Biot because this is the, so here according to the T is equal to constant, the volume is inversely proportional to pressure. So here this process is taking place. What is the process then? The change in the state of the system, that is called as the process. So the processes they study the important processes, that is the reversible and isothermal process. Now, if this change is very small, then this process is also. Suppose then we can write here like this. Then this change is, suppose there is a decrease in the, and this pressure, right? This pressure is infinitesimal small change is there, right? Decreases by, so this P external, P minus D, right? P minus D, P external. Opposing force, and here there is driving force. It is because of the ideal gas, right? So here there is some change, right? It is here the change is going to take place, very small change because of the small change in the pressure. Then again next step, again next step. In this way, number of steps one can decrease the pressure, and finally the change occurs like this, and finally this to this. So here the change, there are number of steps, very small changes taking place in one step. So there are, this is the process, and if the change is very small, infinitesimally, right? Or it is also known as QG step. That is very small change taking place. Also, this is also known as infinitesimal change. Infinitesimal change. That is very simple, right? Same. What is meant by reversible process then? If the process carried out very slowly, where the driving force and opposing force are nearly same, or there is very small difference, infinitesimal difference is there. Okay, so the process is said to be a quasi-static, right? Quasi-static. Very simple is there. Then we can write here for the reversible process and irreversible process. Reversible. What is the definition? How you define the process in which the driving force and opposing force are, the process in which driving force and opposing force are differ infinitesimally and this driving force, okay, or opposing force. Okay, generally the opposing force, that is external force, opposing force, it changes infinitesimally. Then what happens? Then reverse change can be occurred. Then reverse change can occur. So what it means? That is the reaction taking place both direction. Okay. The process can change, can reverse in both directions. In both directions. And it is very slow, right? It is very slow. Why it is very slow? Because there is an infinitesimal change, very small change in the opposing force, right? So here there is therefore number of steps, very slow or very slow. That is, it is said to be a quick step. Quick step. It is step. Okay. Now also there are number of steps. Number of steps in which the changes taking place infinitesimally, very small. Very small changes taking place in the opposing force. Therefore, this piston goes up very slowly. It takes a long time, right? The change appears to be not happening, right? Suppose this is the original level, then it is slowly goes up, right? And it requires more time. Okay, quick step. So here, as there are number of steps, then what happens? And there is equilibrium. What type of equilibriums are there? Of course, thermodynamic equilibrium, mechanical equilibrium, and chemical equilibrium. In a thermodynamic equilibrium or thermal equilibrium, that is the temperature remains constant. Okay, so there is a thermodynamic equilibrium. Thermodynamic. Okay, thermodynamic equilibrium. That means there are three types: chemical, thermal, and thermal equilibrium means what? The temperature of the surrounding, outer and inner, right, is almost same. Almost remains same. To maintain, okay, thermal equilibrium, it is not change. Then the mechanical equilibrium, the particles or mechanical work is not done. Ions, molecules, they are also not changes with time, right? Here, all the conditions are in equilibrium with surroundings, system and surroundings. There is a equilibrium, and because there is a very small change, right? Then, because of this thing, what happens? As there is equilibrium, therefore, what happens? The energy is same. That is, no dissipation of heat energy. There is no loss. That is, it is conservative type of the process. Energy given conservative. And because of this, what happens? Therefore, all these heat can utilize to done the work. To done. That is, what happens then? It is a condition for to obtain maximum work. Because every step there is equilibrium. and therefore system and surrounding there is no much heat loss is there. Okay, and to obtain the maximum work during the displacement, then this is one of the conditions. Always isothermal and reversible processes gives the maximum work. Okay, because of this, what happens the next? It is the number of steps, the change is very small, therefore this process takes more time to occur the final change. Suppose there is a 1 kilograms of this mass is there, and from this half gram is taken out, again half gram, again half gram. In this way, the very small proportion of the opposite force is decreases, and the process is going to very taking place very slowly. The value increases or expansion taking place very slowly to attain the final value. Okay, so the initial state to final state, system attains the final state very slowly, right? So this is a very slow process, and therefore it is artificial arrange process, because generally naturally occurring processes are the first one and they are irreversible type of process. Okay, for example, what types of the examples are there? Example is there, for example, H2O, that is ice. Okay, ice, and 0 degree Celsius. Okay, it converted into the H2O liquid. Or again, the freezing of the water at 0 degree Celsius. Simple. This is a liquid. If you change the temperature very slightly, or any other process very slightly, then either the reaction shifted to the right or shifted to the left. Either this reaction taking place or this reaction taking place, depending upon the opposing force and the opposing force or driving force. Okay, there is a infinitesimal change. This is a very important word. That is there is a very small difference between the driving force and opposing force. Depending upon which one is more, if driving force is more, then the expansion taking place. And if the opposing force is more, then what happens? If you add here some mass, very small, half the gram in this one, so what happens? It will get compressed. So here compression can be taken place. So if the value decreases, so here the expansion, right? So there is a displacement of this piston, which is a frictionless piston, can be either compressed. In compression, it can be work is done. When the displacement taking place, work is done, because work is equal to F into V. Okay. So here now one can consider the work of compression or work of expansion is depends or is possible because when or it depends upon driving force and opposing force. Okay. Now in a reversible type of the process, firstly it is a very slow process, and because of this very slow process, there is every step there is an equilibrium between system and surrounding. Now this is the system. This is a closed and flexible type of a system where the heat can be enter inside, it can be enter outside. Okay. So here, so as it is required to maintain the temperature. Always this boundary is always a thermal boundary. Thermal boundary means the heat can be exchanged with surrounding. Okay. Now this is about the reversible process, and where opposite force and this driving force, they are differ very slightly depending upon their values, either compression or the expansion taking place. There are number of steps, the change is very slow, right? And because of this very slow change, there are number of steps, and every step there is a equilibrium, right? Thermodynamic equilibrium. That is, there is a equilibrium between system and surrounding, and therefore energy is saved. And this saved energy, right? There is the energy is conserved. This energy is conserved, and all the heats can be converted into the work of expansion or work of compression, whatever it may be. Okay, we are going to study in details about what is the work, how it is the derivation. So here, this is the one of the conditions for to obtain the maximum work. That is, the forces must be reversible because energy is saved, and because of it is very slow. There are number of steps, and every step there is an equilibrium. Okay. Now consider the irreversible type of process. What is irreversible? It is just counter or opposite to the reversible one. Suppose practically what you observe, suppose this is some massive particle, and if you, so this is not a reversible, only one direction, so it cannot be comes into its original position. Okay, so the any water fall or any substance will fall under the gravity, that is irreversible. Or the expansion in vacuum, right? There is a vacuum on side or right? Examples, irreversible processes. Examples. This is the example for this is the example reversible process. Okay. So here very famous diffusion gas or gases. Suppose there is a one compartment of hydrogen, right? And there is some what is there, right? So here hydrogen molecules are there, nitrogen molecules are there. If you open the partition, what gas can be introduced together here immediately. Now further separation is not possible. There is, it is not found that in one corner of the room there is hydrogen, one of the room there is nitrogen. Nitrogen is heavier, so it is at the bottom. Hydrogen is lighter, it is at the surface, above surface. It is not happened because of the diffusion process is irreversible, spontaneous process. Naturally occurring processes are generally the spontaneous one. They cannot be reversed. They are fast, and there is energy loss taking place. So maximum work cannot be obtained in such a processes. Okay. So here we are going to study the next type of the processes, that is the thermal and adiabatic type of the processes. Okay. Dear friends, as per discussed, the reversible processes are artificial one because you have to arrange the external conditions, that is opposite force, right? There is a very small change in a system. So as discussed here, if this is the ideal gas, so this P is equal to N. Okay, P is equal to N. So this is nothing but the internal, or it gives this pressure gives the acting as a driving force. This is nothing but the opposite force. Force. Okay. P external, this can be shown here, P external, okay. Now, what is mean by isothermal process? Isothermal. Iso means isothermal and adiabatic. Okay. Isothermal and adiabatic processes. So here, one thing is that we have isothermal, that is the process taking place at constant temperature throughout. So here, how the temperature maintain constant or heat? Suppose there is some endothermic reaction, it is your temperature tends to increase, but we have to keep the temperature constant. Therefore, whatever heat is your, this must be drawn out, right? So this heat can be given by the system, or sometimes if the some endothermic type of the reactions are there, when the reaction started, it requires heat. So here it needs heat, otherwise temperature is going to fall. So to maintain the temperature from the external source, heat can be provided plus. That means this boundary of the system must be thermal. Boundary of system must be thermal. Right? So it can be exchanged with the surrounding, right? So as to maintain the temperature. Also, it should be a closed system. Is what type of the system is there? System is either open or closed. Closed type. Okay. Now, at constant temperature, that means what? Temperature is constant, implies there is T1 to T2, they are same and it is equal to T. So T2 minus T1, there is same, that is 0. Okay, delta T is equal to 0. No change. As the temperature remains constant, what it indicates? The internal energy not changes. Internal energy means the kinetic energy and potential energy, right? The vibrational, rotational motions are set, right? Or bonding energy is set, not different. There is internal energy, that is internal energy not changes. That is what it means, delta U is equal to 0. Right? So this is the one of the system is open or closed system. Like this. It may be flexible. Now what is about the adiabatic process? Adiabatic. In this case, the famous example is thermos flask. The process taking place in a thermos flask. That is, system is isolated. That means what? Heat neither. Suppose this is the thermos flask where there is a vacuum. The heat cannot be entered from surrounding the system, or it cannot be given out, right? So in this way, this is not possible. It cannot be a change, right? So whatever change is taking place, it may be an expansion or maybe a compression, but it is taking place inside of the system only. So what happens here? The Q, heat change of the system is 0. Okay, heat change is 0. Therefore, heat change is 0. That is Q is equal to 0. Okay, Q is equal to 0. Adiabatic change. Okay, suppose this is a some of the adiabatic system, and so this is the external, right? There is some whatever reaction which is there, right? Suppose there is a piston. Now if exothermic reaction taking place, piston can be converted, but displacement taking place at the cost of, that means using the internal energy of the system, right? Sometimes if the exothermic reaction taking place, one breaks, right? New bonds are formed, and during this it is evolved, right? It is a part of the internal energy. Then this is, right, this internal energy is utilized to push this piston. So here the internal energy is utilized to done the work. Or sometimes if you apply the pressure, then what happens? Apply the pressure, more pressure apply like this. What happens? Compression taking place, right? Right. So here, but whatever is the changes taking place, it is because of its internal energy, right? Internal energy. This applied work or this work energy is stored in the internal energy. Internal energy increases in this case. Okay, we are going to study in details after this one by one. First, we have to consider the first law of thermodynamics or this formula. Before the derivation, consider one. Right. Now, if energy is added in system as heat, Q, and work, then what happens? Then its internal energy increases. That is increases. Right? That is, what is the formula? That is, the internal energy of the system is equal to Q plus W. Okay. This is a very important formula. This is the first law of thermodynamics. If we add the energy in the form of heat energy or in the form of work, because work needs the energy, work is nothing but the energy. To done the work, always energy is required. Okay. So the internal energy of the system is going to increase. Okay. Now in this case, as using this law, one can explain the isothermal process. Here, delta E is equal to 0. 0 is equal to Q plus W. Therefore, minus Q is equal to W. Or also Q is equal to minus W. Then, in the case of adiabatic process, Q is equal to 0. Therefore, delta E is equal to W plus. Or secondly, this can be also written as delta minus Q is equal to minus W. What it indicates? Okay. So consider one by one. Minus Q, that means minus sign, always minus or negative sign indicates given out from system, and positive sign indicates positive sign indicates adiabatic system, whatever it may be. It may be over, it may be. So here minus Q indicating heat is given out from the system and work is done. This is plus, work is done. So what it indicates, that is work done on system. Then to maintain the temperature when the work is done, right, compression, the temperature going to raise, but we have to maintain the temperature, that is isothermal process. Then to maintain temperature, the heat is evolved heat is evolved. Okay. Or second, so this is the compression taking place. So this is a isothermal compression. Right, work of compression. Right, this is the work of isothermal compression. Okay. Now consider Q is equal to minus W. The sign plus is there. Now if we add heat into the system, then temperature tends to increase. To maintain the temperature, system does the work and some of the heat energy is converted into the work. So here what happens then? The heat is added in system, then work done by system to maintain temperature. Okay, so this is nothing but what happens then? The work done by this is the work of expansion. Okay, work of expansion. Now consider the next. Plus delta of the adiabatic process. The increase in the internal energy of the system when work done on the system. What it indicates? When work done on system, then its internal energy increases. So this is work done on the system. So what happens? Of course, compression taking place. So this is the adiabatic compression. Okay, adiabatic compression. And one more term here, minus delta U or minus W. That means minus sign that is given out. Right? So here, if work is done by the system, because to done the work, heat energy is utilized and the energy of the system decreases. So here, if work is done by system, right? That is minus W. Then to maintain the temperature should not be fall. To maintain the temperature, what happens? Its internal energy going to change. Its internal energy decreases. Right? So work is done by the system. So what happens? The adiabatic, it is the work of adiabatic expansion. Adiabatic expansion. So in these cases, isothermal processes. 8 minutes. So here, the adiabatic processes, as per discuss here, one of the example is thermal flash. Whatever changes taking place, whatever work done is inside of the system, where total heat content of the system is said to be 0, and because on the basis of this first law of thermodynamics, one can find the adiabatic compression and adiabatic expansion. These are the two equations. Okay, here very important. And for the isothermal, these are the two equations. Here, this is the work of expansion, and this is for the work of the compression. So here, as this is the, if we consider the ideal gas is there, so here P is equal to nRT. Okay, so in isothermal process, the maximum work obtained can be given as NRT. As PG is equal to NRT, so one can replace here the flame is equal to, okay, so P3 log of P2 upon P1, or for P1 P1 is equal to P2 P2, therefore this can be also as P1 upon P2. Okay, the derivations or the maximum work obtained in isothermal process we can derive it in the next lecture. Let me stop here today. Thank you.